This is a simple experiment to demonstrate the stability of road vehicles. And to start with, I'm just going to use a large matchbox to represent the vehicle. And you can see it there resting on the slope with one of its smaller faces actually on the slope. Now you can measure the steepness or gradient of the slope by finding the height of the raised end, and at the moment this is 5 centimeters, and dividing it by the length of the slope, which is 50 centimeters. So this means that the steepness or gradient is 1 in 10. I'm now going to increase the gradient and see when the matchbox actually falls over. And this happened at very nearly a height of 10 centimeters, which means the slope had a gradient of 1 in 5. Well, I'm now going to replace the matchbox, but this time with one of its larger faces on the slope. Let's try again, increasing the gradient. Now the area of contact is bigger, the base is bigger, so now yes, the high end of the slope was, as near as I can see, 18 centimeters this time. So we do the same thing, divide 18 by 50, and we get a gradient of just under 1 in 3. Right, we're now going to use something a bit more like a proper road vehicle. It's a model of a van, and this is actually a Mercedes Sprinter. So let's see how stable this one is. So we can raise it to 20, hasn't tipped yet, 23, 24, 25, and there we are. So the van has rolled when the end of the slope was raised to 25, and that makes a gradient of exactly 1 in 2. Now here is our last car, and this is a Subaru Impreza. We'll see how stable this one is. So let's try again. Off we go. 20, 25, 30, incredibly stable, 35, 37, it's beginning to slip. So at 37, the Subaru slides. It doesn't actually roll at all. It doesn't topple down the slope at all. So, having seen these various cars and the matchbox, can you think of some conclusions to the experiment as to what makes a vehicle stable? What are the properties of a road vehicle that will mean it is very unlikely to topple over and therefore very unlikely to roll when it goes round a corner?